Hello everyone and welcome back to Greenstat Hydrogen webinar series. I'm your host Prasadini Wickramasinghe, an energy analyst, and I coordinate our activities at Greenstat Hydrogen in Sri Lanka. It's wonderful to see many of you joining us today from the different part of the world. Thank you for taking the time to be here with us. Today's webinar is titled Key Findings from the IPCC Sixth Assessment Report and Plans for the Seventh Cycle. The Intergovernmental Panel on Climate Change, or IPCC, is the world's leading body for climate science, shaping global policy and public understanding through rigorous research and assessment. It is my pleasure to warmly welcome our guest speaker, Professor Jim Skea, the current chair of the IPCC and one of the most respected voices in climate mitigation and energy transition. Thank you, Professor Skea, for accepting our invitation. We are truly delighted to have you with us. In today's session, Professor Skea will share the key findings of the IPCC Sixth Assessment Report, explain how they connect to the Paris Agreement goals, and highlight important knowledge gaps that must be addressed to achieve global climate targets. He will also give us a forward-looking perspective on the upcoming seventh assessment cycle. With decades of expertise in climate science, policy and innovation systems, Professor Skea brings expressions of knowledge and insights to this discussion. Before we begin, allow me to briefly introduce who we are. Greenstat Hydrogen is a consulting company dedicated to advancing renewable energy with a special focus on green hydrogen. Our Centre of Excellence for Hydrogen, based here in Sri Lanka, is committed to knowledge sharing, capacity building, and fostering collaboration across the globe. We work closely with universities and international experts to promote hydrogen safety, technology, policy, and the full hydrogen value chain. A few housekeeping notes before we start. Please type your questions in the Q&A box anytime during the session. We will address these questions during the Q&A segment in the end. A recording of this webinar will be shared with all registered participants in the coming weeks. Additionally, we would also like to extend our sincere thanks to the National Science Foundation for promoting this event through their STMI's platform. Without further ado, let's dive into today's session. Professor Skea, the floor is yours.
Okay, thank you very much, and thank you very much for the invitation to speak at this event. So good afternoon and good morning from London, which is where I'm based at the moment. Now, as Prasadini has said, I'm going to do two things, essentially. I'm going to talk about the findings from the last IPCC report and also look forward to what we are currently working on. But in fact, let me add a third element to that, because what I think it would be useful to do is just to explain what IPCC is and how it actually works, because it will give you some kind of explanation as to why we come up with the findings that we do. And I'm hopeful that I am now sharing a screen with you.
Yes,
if I can get it full screen now, that's good. Okay, so three things. What is IPCC? What are the key findings so far, and what do we plan to do? So on the first part, what is IPCC? Our role is we are the UN advisory body on climate change and climate change action, and our job is to assess the scientific, technical, and socioeconomic literature relevant to understanding climate change. And just to emphasize, we're absolutely neutral with respect to policy. We don't make recommendations, we don't advocate, and I might also say we're neutral with respect to technologies. We don't promote or oppose any particular technologies. And to make one point, we don't actually conduct our own research. We assess the scientific literature. We put together, we synthesize what is out there already. We have an incredibly complicated structure, so let me do it very, very briefly. On the left-hand side, a reminder that the I in IPCC stands for intergovernmental. The members of IPCC are 195 governments. They are not individual scientists, and they meet in plenary sessions roughly twice a year. The governments elect the scientific leadership of IPCC, known as the Bureau, for each cycle. That includes myself as chair and includes vice chairs and the co-chairs of the specific working groups of IPCC. And the Bureau is elected for an entire IPCC cycle, which lasts for up to 7 years. So the current cycle started 2 years ago in 2023, and it is not due to be completed until about 2030. The engine room of IPCC are the working groups, and we have 3 working groups in IPCC. One working on the physical science, the second one looking at impacts, adaptation and vulnerability, the third one, working group 3, looking at mitigation or emissions reduction, and my guess is that is where most of the interest for this session is going to be. And we have a further element of IPCC, the Task Force on National Greenhouse Gas Inventories, which develops guidance for countries on how to report their emissions and their removals of greenhouse gases to the UN Framework Convention on Climate Change. So it's heavily focused on methodology. But what we need to emphasize on the right-hand side, the actual IPCC reports are written by hundreds and hundreds of scientists and experts from around the world. And they're the key for the work that actually gets conducted by IPCC. And I might flag right from the start that we aim for a balance between scientists from developed and developing countries. And we are pretty much operating at parity now, same numbers of developed and developing country scientists. So how do we actually produce the reports? And I'm not going to go through this slide in an awful lot of detail. But just to emphasize, once our governments have agreed to produce a report, it can take 3 to 4 years for that report to actually emerge. And it goes through basically 10 steps. First of all, scientists get together to scope out the outline of the approach, a draft outline. And at stage 2, the governments then look at this draft outline and reach agreement on what the outline of the report will be. And that will consist of a set of chapters, and within each chapter, a set of bullet points giving a sense of the scope. And it's only after the outline is agreed that governments can nominate authors to participate in the report, and it is up to the Bureau, the elected scientific leadership, to select the authors. So several stages already, and we haven't even started to write the report. The reports then go through 2 main drafts, a first draft, which is sent out for expert review, and a second draft, which then goes out for a combined review by governments and experts. And it's worthwhile noting that every single comment that comes in, and there may be hundreds, if not thousands, on individual chapters, are responded to individually. And authors will say whether they accept the comments, or if they do not accept the comments, they will record the reason why they do not do so. And both the comments and the responses are published once the report is finally agreed. Once we've gone through these 2 review processes, a final draft of the report is produced alongside a so-called summary for policymakers, a shorter document that summarises the key conclusions of the report. And that summary is then reviewed again by governments, and the summary for policymakers is revised. And finally, at step 9, a draft of the summary for policymakers is taken to a full plenary session of IPCC, where we go through it paragraph by paragraph, line by line, and word by word to get consensus agreement between the governments and scientists that this is a proper record of the underlying report. And it's only at that stage, after we've been through all of that, that we can actually publish the reports and present them to the world. So, just to emphasize, it is the most rigorous scientific process that is conducted, I think, anywhere. And its unique contribution is that it is a consensus between scientists and policymakers. And that gives the report their power, and it means why they are accepted as the most authoritative science available on climate change. Now, turning to the conclusions from the sixth assessment cycle, which concluded in 2023, I would just like to flag that on the shelf next to me, there are 30 kilograms of reports running to 10,000 pages. And it is a challenge to summarize all that in 15 minutes or so. You can imagine 10,000 pages, 15 minutes, and many 100 pages a second almost that you need to get through. So one of the ways that we have done this is to summarize the conclusions of the reports in terms of the 3 goals of the Paris Agreement, which are the long-term temperature goal, which is number 1 on this slide, holding global warming to well below 2 degrees and pursuing efforts to limit to 1.5. The second goal, which is about increasing the ability to adapt to climate change and foster resilience. And the third goal, which is making financial flows from developed to developing countries consistent with a pathway towards low emissions and climate resilience. And doing this all in the context of efforts to promote sustainable development and eradicate poverty. And one thing, often a lot of attention is given to goal 1, the long-term temperature goal, but it is the case that each of these goals is of equal importance, and we cannot achieve one without achieving the other. We will not get people coming forward with ambitious emission reduction targets unless, for example, there is progress on, particularly on number 3, on the question of financial flows. Now, I'm not going to go through all of these, but what I would like to start with is actually number 2 on adaptation and resilience, because this really explains why we're doing anything about climate change in the first place. So first of all, if you looked back at previous IPCC reports, climate change was something that would happen in the future. This is no longer the case. We can already observe the impacts of climate change around the world. And indeed, we are highly confident that human beings, for example, have caused observable changes in extremes of temperature around the globe. And we are extremely confident about that conclusion in all parts of the world, including South Asia, where you're based. So this is something, climate change is already happening, and it's not just hot extremes, it's more intense weather events, flooding, drought, wildfires, all associated already with climate change. And as the World Meteorological Organization has already concluded that the world, in terms of a long-term trend, has warmed between about 1.3 and 1.4 degrees since the pre-industrial level, it is understandable that we can see these impacts. And these impacts can only get worse as we move into the future. So something that our scientists have done is to develop these diagrams with the striking colours on them, the so-called burning embers diagrams. And they do what it says on the tin. The more intense the colour, the higher the risk associated with climate change at different warming levels. And you can see warming above pre-industrial between 0 degrees and 5 degrees on the vertical axis. And just to give a sense of calibration, the purple risk, the more intense colour, are very high risks, which imply that they affect huge numbers of ecosystems, large numbers of exposed populations. The risks are severe and they are irreversible in nature. So that's what the purple risk means. The moderate risks at the other end of the scale are sort of risks that you can live with, but they are detectable impacts of climate change. So it gives you a sense of the scale there. So if we look at land-based systems on the left-hand side, we can see that the risks tend to accelerate. They move from the moderate to the high level for example, between 1.5 and 2 degrees for wildfires, permafrost degradation, biodiversity loss, and tree mortality. So you can see that was one of the reasons that the evidence that IPCC produced about the change in levels of risk between 1.5 and 2 degrees was one of the reasons why the long-term temperature goal in the Paris Agreement was formulated the way it was. If we turn to the right-hand side of the system on ocean and coastal ecosystems, we can see that perhaps the risks for most of these systems are happening at a higher level of warming, with the one exception of warm water corals, where we can already see bleaching and loss of coral reefs in various parts of the world. So at 2 degrees warming, we will lose basically warm water coral reefs. Even at 1.5 degrees warming, the decline will be probably about the level of 3/4. So we're looking at really severe impacts. And just to note that the impacts are not just about ecosystems, they're about human systems as well. Because global warming and higher ocean temperatures will have effects on the yields of fisheries and agricultural yields, with consequences, for example, for global markets in agricultural products and food prices. So these are the kind of consequences we'd be looking at. So that's an explanation of why I think we're worried about climate change, very briefly. Now, I'm going to spend a little more time on basically the long-term temperature goal and the issues associated with that. So, you've seen the emphasis on 1.5 and 2 degrees in the Paris Agreement, and I will come on to whether 1.5 is achievable in just a couple of slides. But what we did in the last cycle was to look at global emission pathways associated that would lead and allow global warming to be limited to 1.5 degrees on the left-hand side and 2 degrees on the right-hand side of this diagram. And the key point, carbon dioxide accumulates in the atmosphere, so it's cumulative emissions that matter. So global warming will not stop until net carbon dioxide emissions reach zero, i.e. you take as much carbon dioxide out of the atmosphere as you put in. And on the left-hand side, you can see for 1.5 degrees warming, carbon dioxide emissions would need to reach net zero around the middle of the century, around 2050. But emissions of total greenhouse gases, which include methane and nitrogen oxides, could actually reach net zero later, towards the end of the century. It obviously gets a little easier if you're limiting warming to only 2 degrees. The net zero for carbon dioxide moves out to 2070, and in fact, greenhouse gas emissions as a whole do not reach net zero within the 21st century. So that's the kind of the strong messages why we have the emphasis on net zero. Now, one thing to flag is because we in aggregate reach net zero, it does not mean that all sectors would reach net zero at the same time. And what this slide does is to illustrate what happens in different sectors in a pathway that limits warming to 1.5 degrees at the level of aggregate emissions, so net zero around 2050. The first sector to go to net zero would be land use and land use change, which is effectively avoiding deforestation, afforestation activities. That reaches net zero around 2030, at which point, growing trees would be pulling more carbon dioxide out of the atmosphere. The second sector to go to net zero around 2040 is energy supply, which obviously includes electricity and would include the contribution of hydrogen, for example. And the demand sectors, transport, industry and buildings, and non-carbon dioxide emissions, in fact, do not reach net zero during the 21st century. There is no credible way of removing greenhouse gases from the atmosphere in these sectors. but it's just to emphasize the importance of land use and energy supply as early movers in terms of climate action. Now, to bring the time schedule forward a bit and look just out to the year 2050, this is where the bad news start, because very obviously when we produced the reports in 2023, we were looking back at literature that was published, that was looking at scenarios that started in 2020. And obviously 5 years have passed since then. The world has moved on. And sadly, we are roughly in the pink slice at the top, the trend from implemented policies with emissions increasing gradually. And the latest statistics from the International Energy Agency and others are quite clear that emissions are continuing to rise. Starting from 2020, had we wanted to limit warming to 1.5 degrees, this is represented by the blue slice. We would have had to approximately halve emissions during the 2020s. Clearly, that has not been happening. And even limiting warming to 2 degrees, we are far adrift from. The purple slice with the bend in it at 2030 refers to what would have happened had countries stuck with their nationally determined contributions, their emission pledges out 2030. That would have resulted in a slight reduction in emissions by 2030. But with that, 1.5 degrees would have been beyond reach, and to limit warming to 2 degrees, it would have needed very dramatic reductions in emissions after 2030. And I don't need to tell you just how challenging some of these indicated pathways would be. So we operate quite slowly. We have had we've produced no new reports since 2023, but the United Nations Environment Programme produces an emissions gap report every year, and they assess what the consequences would be of current and pledged activities. So their best estimate on this slide, if we carry on with current policies, the world will warm by about 3 degrees by the end of this century. And looking back at the burning embers diagram, I don't need to tell you what the severity of the impacts we would see. In the very best case at the bottom of the slides, where all of the nationally determined contributions are met and all of the aspirational net zero pledges that governments have made for the middle of the century were achieved, then we could limit warming to just below 2 degrees by about 1.9. So 1.5 now effectively very difficult to get to. Just to say, it is highly likely that we will exceed 1.5 degrees of warming within the next few years. But that does not mean that it's absolutely impossible to limit warming to 1.5 degrees by 2100 by removing carbon dioxide from the atmosphere and effectively cooling the Earth again. It's possible in principle, but the difficulties of handling that will be addressed in our next reports. So now, that's all a very negative picture, but let me first of all say how much progress we have made in some respects in the last 10 to 15 years. So, looking at the costs of photovoltaics, onshore wind, offshore wind, and lithium-ion batteries, we have seen absolutely huge declines in the cost of these over recent years. So, about 80% reductions in the cost of solar PV and lithium-ion battery packs. And onshore and offshore wind have also declined significantly in cost. What the yellow band in the cost one shows is the cost of generating electricity from fossil fuels, the kind of range that might be covered. And we can see that renewables are competitive effectively with fossil fuel electricity production in many parts of the world. And you can see that this has been reflected in the rates of market adoption, just huge take-ups of PV and other forms of renewable energy, to the extent that wind and solar energy now account for about 12% of electricity supply around the globe. That's the good news. The bad news is it has been concentrated in specific places, specifically China, Europe, and North America. And there are big challenges in terms of capital cost barriers and grid integration issues to get it adopted more widely, but significant progress is being made. We also, in the last report, identified the options available to reduce emissions in the near term, by which we meant roughly a 10-year time horizon. That was starting in 2020. We're obviously now 5 years on. The big potential on the energy side has been through renewables, as I've said, wind and solar energy, but also significant contributions potentially from bioelectricity. And note at the bottom of the energy slice, reducing methane emissions from oil and gas systems, which is an opportunity that has been staring us in the face and has not been taken up so far. For industry, a variety of different measures, but I think of relevance here is the question of fuel switching, which is the biggest contribution to the potential in industry, which includes switching to electricity from fossil fuels, from things like coal and oil to natural gas, bioenergy, and hydrogen, which is part of the picture there as well. I should say that the colour scheme is of significance here because it reflects the unit costs of the different options. And you can see that there are several areas in which the costs are lower than the reference costs. And negative costs, it would make sense to do these things even in the absence of climate change. And a lot of the renewable energy potential, some of the methane reduction emission potential falls within that range. So, and most of the potential is available for less than $100 per ton of carbon dioxide equivalent. And for reference, the price of emissions in the EU emission trading scheme is probably around the 70 to $80 equivalent at the moment. So it does look quite cost effective. Now, I know hydrogen's of a particular interest in this context. In our energy chapter in the last report, we did specifically look at the role of hydrogen. And I think one of the points that we made is that hydrogen would have its use in the future, but the dominant mode of fuel switching in the energy sector would be towards electricity, with hydrogen having advantages in specific geographies and in specific markets. And I think that's a point that is quite important to be made. Electrification is going to be the dominant theme. And when we looked at the hydrogen value chain, we broke it down into production, transportation, and storage and utilization. So in terms of hydrogen supply, we distinguish between the non-electric and the electric routes, the green hydrogen basis. And I think an important point to make that the non-electric routes, steam methane reforming, is currently the cheapest way of generating hydrogen. That is in the right-hand side at the top, current costs between $1 and $2.7 per kilogram. But if you look to the future, especially if we can get the improvements in the performance of electrolyzers that we've had, for example, for solar PV and batteries, then in the long term, the cheapest potential lies with electrolytic green hydrogen. You can see the range 0.9 to $3.9 per kilogram of hydrogen. So strong messages there about the long-term potential for green hydrogen. And we also looked at more specifically at the markets part of the picture. So within the energy system, noted that hydrogen storage can provide short-term and long-term balancing in energy systems. Hydrogen is very close to commercial for some primary steel making in some parts of the world. And within the transportation sector, although electric vehicles are likely to be the dominant mode of decarbonisation, There are specific markets and specific places in which low greenhouse gas emission hydrogen, for example, offer mitigation potential, perhaps more in the heavy freight transport rather than the small, lighter vehicles. So these are the kind of messages we had around hydrogen. I'll skip that given time. But one thing I wanted to finally pick up in terms of our findings was the question of financial flows. And one of the things that we did was to compare current financial flows for different kinds of mitigation against what would be needed to put us on pathways compatible with the Paris Agreement. And the short story is that financial flows would need to be scaled up by between a factor of 3 and 6 compared to current levels if we were going to put ourselves on a pathway towards the Paris Agreement. And we have divided these up, split it up by the different sectors, by different types of economy, and by different regions. And just not going into the detail, but the smallest gap, a factor of only 2 to 5, is actually in the energy supply side and electricity. The gaps are actually bigger for energy efficiency, for transport and agriculture, forestry and other land use. And the gaps are bigger for developing countries than they are for developed countries. So very strong messages there. But just to flag, again, on the optimism side, we have already avoided gigatons of greenhouse gas emissions through existing policies and actions. Climate legislation covers half global emissions, and a fifth of global emissions are covered by some kind of carbon pricing. And we have all the tools, the policy tools that are available. We know that they work, they need deployed more widely, and their ambition needs enhanced. So as well as carbon pricing, regulation, standards, sunset requirements on obsolete technologies, information and advice, and in the concept of just transition, skills, training, and supply chain development. So we have everything. Now, let me just very briefly, I'm keeping an eye on the time, looking at our plans for the Seventh Assessment Report. We already have a couple of pieces of work underway. One, a special report on climate change in cities, which we are just moving to the review of the first draft. We have a methodology report on short-lived climate forces, which includes things like nitrogen oxides, volatile organic compounds. I might say there was a big debate among governments about whether this would cover hydrogen, but it does not, because it was thought to be premature, as we don't actually understand whether hydrogen has a positive or a negative impact on climate change. And so we may move on that once there's more evidence from the science. Now, we will be producing the 3 usual working group reports in the next cycle: physical science, impacts, adaptation, vulnerability, and mitigation. And there will be a synthesis report that pulls it all together. And the current stage, we are just in the process of appointing all the authors to produce the reports. And the first lead authors meeting is going to take place in Paris this December. And we should expect the reports to appear in mid-2028, though the precise schedule has yet to be agreed by governments. Now, just to flag specifically on Working Group 3 in the mitigation side, we have a report that will have 15 chapters altogether. The first slice, chapters 2 to 4, is apparently a global picture, looking at a time-focused way of looking at things. Chapter 2, looking at back where we are now, how we got there. Chapter 3, scenarios for the 21st century, along with Chapter 4, a big emphasis on sustainable development, mitigation, equity issues. Chapters 5 to 7, cross-cutting issues about policies, the way that finance and technology cooperation can help. And then the main majority part of the report, chapters 8 to 14, sectorally focused. And there will be a lot of emphasis within that in chapter 9, in chapter 10, perhaps in chapter 11, on the role of hydrogen as potential one route forward. We still have a couple of things outstanding. The governments would like us to produce a methodology report on carbon dioxide removal technologies and carbon capture utilization storage, which has some implications obviously for blue hydrogen. We were close to agreement that at our last session, but we could not get countries to agree on whether or not we would cover the removal of carbon dioxide from water bodies, specifically oceans. And there's also the synthesis report, for which I'll be responsible, which will be scoped later in the cycle. And with that, I think that concludes my remarks. Thank you for your attention. And I'm very happy to stay on and answer a few questions and respond to comments, but I'll bring it to a close there.
Thank you, Professor Skea, for your insightful session. You have given us a lot to think about from the science behind climate change. We will now open the floor for the Q&A session. And as we come to the close of today's webinar, I invite Preethika to deliver the vote of thanks. Preethika?
Yes. Hi, thank you, Prasadini. Am I audible?
Yes.
So on behalf of Greenstat Centre of Excellence for Hydrogen, I am Preethika Murugesan, and it is my honor to thank our distinguished speaker, Professor Sir Jim Skea, Chair of the IPCC. Thank you, sir. And thank you for sharing your valuable insights and for patiently answering the questions. Thank you for your extremely amazing presentation on the Sixth Assessment Report and your vision for the 7th cycle. Your words have inspired us and given us much to think about. Thank you. To our audience, professionals, researchers, students joining from around the world, a heartfelt thank you. Without you, this event would not be possible. Your time, attention, and active participation have made it a success. Thank you. We also extend our thanks to the National Science Foundation for helping us reach a wider audience through their STMIS platform. And with that, we close today's session. Thank you once again, and we look forward to seeing you at our next event. Thank you.
Thank you very much. Bye-bye.
Thank you.